this, the first thing you might need is a board and a lovely assistant to outline your size in it, because you want this to be custom. So there's my board. Next, you must take your ladder from the garage and make a subframe. I will miss that ladder. I had to cut it up. And then the first big design challenge is the wheels. In a lower powered, low speed vehicle, the problem is rolling resistance as much as air resistance, if not more. So inline skate wheels, real good bearings on each side of them, but the axle itself is also mounted in these tubes, which will be mounted, and essentially giving you a free-floating axle. So one more level of rotation. As friction starts to turn the axle, it can turn, and you'll get some free rotations. In the back, did even greater. The tubes themselves are mounted in pillow block bearings, so in theory, one more level of rotation. And this thing should really roll. Let's see. Okay, big day. Got the wheels and front axle in. No steering yet, but it should roll. Hopefully, hopefully. Mwah. Rolling. Okay, I'm satisfied with the rolling on this. Little wheels are going to mean a very flat surface, but that was the design compromise. So next, the steering. I'm going to be on my elbow, so I thought a back and forth paddle situation would be a complicated solution to an easy problem. And these are gadgets I found at the hardware store. Put it all together, and it should equal the wheels turning left and right when I go forward and back with the handles there. So pretty much that's set. The next step, of course, would be to finish the top on this. I wanted to follow my body exactly, or as close as possible, with as aerodynamic shape as possible. And I came up with, this. It's got a very small frontal area, maybe less than 3 square feet. I think I measured it. So not much of a hole to poke through the wind. Like I said, I was trying to get for the easiest or best aerodynamics, which in my understanding is building pressure slowly or evenly and releasing pressure evenly. So each of these lines on there was with that in mind. And, well, it's built like a model airplane. A little bump in the back is for my heels, believe it or not. So that's how tight it is. This is on a crate, ready to leave California, where this thing started. Next you'll see it will be in Kentucky, in a basement. That's just how life rolled. So here we go. Basement, putting the balsa wood covering on it. It wasn't going to support anything, so I could go as light as I wanted to. So balsa wood was the thing. And I'd worked with it before. And smooth it, and smooth it. And put the window in, smooth this more, and then the veneer. This is the fun part. I wanted to make this look as close as I could to a 50s like Chris Craft outboard boat, and that was my idea. This is what I came up with. There's the top finished, and then the top I got some veneer on it, and it shine. And the design I just thought would be a cool design. I have that tattoo, neither here nor there. So next step. Motor, 350 watt commercial electric scooter, toy scooter motor. I was going to have four panels at 100 watts each, so a 350 watt motor I thought would be about right. And just testing it on the 2 panels, it seemed to be turning it fine. I can mess with the gearing on this with that little chain. You notice the drive wheel, and this is going to be the drive wheel, is soft and spongy, where the support wheels were hard and thin. One, you want low rolling resistance. On this, you want heavy rolling resistance. And it wasn't going to support the vehicle. So my idea was to hinge this, and I'm getting ahead of myself a little bit here. My idea was that the least amount of pressure on the wheel and still not have it slip underneath the vehicle would be the optimal rolling resistance, if you will. The opposite of rolling resistance, the optimal grab, and the easiest on the bearings. So when I put this into the vehicle, it was on a hinge. It is just the weight of the motor holding that down. And that was just, I don't know anything about engineering, but I thought that might work better. And there's my other two panels. They came in, and I ordered shirts for myself and crew, just because I thought that would be cool. And yeah. And then fired up the 64 Ford rat rod. Going to drag this thing out to a straight stretch of Kentucky road, which is rare. But I found one semi-locally at a horse farm, which I will, well, thank them for the lending of their road. And yeah, just wanted to get out there, see if this thing would work. 4 panels. Eventually I was going to run this with 12, but 4 panels and that motor. And there's my truck in Bergen, Kentucky. Look it up. 1 stoplight. So I wasn't really worried about traffic. And I had my buddy here help me put it down and set it up. And like I said, we didn't have to worry too much about traffic on this road. I don't think but 1 car came by during this whole ordeal. And like I said, about the straightest, flattest patch I could find. Some of it was covered in shade from trees, which was going to play a role. But I had, I had about 100 yards of sun that I could run this thing on, and see how fast I could go. So here's the area I'm climbing into, basically laying on the motor, which again is hinged, just wires on each side to a toggle switch. Low tech on this. It's either go or don't go. So I was curious to see if it would go.
Deb, you want to help me with this? Put this on. Okay, watch your head. Coming down. Okay. Okay.
Initiating camera.
All right, we're getting in the car.
Okay, I'll wait.
Need help?
He isn't moving.
So very exciting. It is moving, kind of slowly at first.
Going up a little, Tom.
I'll tell you from the inside, it seemed like 1,000 miles an hour. Testing the steering here, which caused the solar panels to start wagging the dog. I solved that later, and the faster you went, the more that seemed to happen, which is drag you don't need. But hey, it's going. And there's the fastest, right as I'm hitting the shade, slowing down, and stop anyway.
Good.
It was fun. It was fun.
Oh, shit.
Spectacular.
Okay. So if you're buying lunch, we'll let you out of there.
Yeah, let me out.
All right, let's get him out.
So just a fun day with my friends on a Kentucky road. Made a couple of passes, brought this out a few days later with some changes into the gearing. Eventually got it just over 20 miles per hour. It was getting a little hard to steer at that point, so that might be its design limit, but 400 watts, 20 miles per hour. If someone's going faster, let me know.